Okay, ladies and gentlemen, good day to all of you. My name is William Chiu from CICT Mobile. So it's really my honor today to share with you about the high cost effective indoor coverage solution in the 5G area. So before this, I also want to mention that our company, the CICT Mobile, is also cover the base station and the small cell and antenna and the vertical industry application products. So for all this solution is produced by our CICT Mobile. But today's topic is only for the indoor DAS and the repeater. So let's say today's topic is divided into two parts. First one is the active DAS, and second one is the repeater. So let's begin by exploring why indoor DAS is so important and necessary in the 5G area. There are two main reasons. First one is when the outdoor micro station cannot provide a good indoor singular coverage in some scenarios, especially in the 5G area for the high frequency band. And also, secondly, more mobile business occurs indoor, which is about 18% of the mobile data traffic occurs indoors. So this is why micro station sites cannot provide good indoor coverage for the operators and our customers in the 5G area, especially for the high frequency band. Secondly, as I mentioned before, the more mobile business occurs indoor, so that's why we need indoor DAS to cover the indoor singular coverage. Okay, then this is the trends and the overview of the active DAS or the passive DAS market worldwide. According to the ABI research report, the worldwide total revenue for the indoor DAS will grow from the $11 billion in the 2021 and into the $33 billion in the 2027. So it's really a big growth in the total revenue. And the total CAGR is about 19%. And also, according to the 5G network innovation seminar in China, the proportion of indoor investment has increased into the 35% in the 5G area. So for the operators, the construction cost of DAS is increasing, and the business scenario has also made the indoor DAS increasingly important. So let's see the traditional DAS face many challenges. As we all know, for the indoor coverage scenarios, such as the medium stadium, commercial center of the building, and the residential area or the hospital, there are so many different kinds of indoor DAS solutions, such as the traditional passive DAS solution, digital DAS, and also the active DAS. For the traditional DAS, as we all know, it's really hard to realize the MIMO due to the hard deployment and unbalanced MIMO performance. Also, the passive DAS cannot be remote monitored, which requires more local inspection. And also for the passive DAS, also requires more antennas or cables or the RU single source due to the single loss in the transmission. And also for the digital DAS, which is hard to support the multiple operator sharing and multiple modes. And also for the digital DAS need to match with the core network, so it's really hard to realize the multiple operator sharing. As for all these problems and demands from our customer, we proposed our solution, the active DAS, the MS-DAS solution, with the simple structure and easy deployment, and the cost reduction in half for the indoor sharing mode. So this is our indoor sharing solution of the MS-DAS. So the MS-DAS is a digital optic fiber distributed system that support multiple operator sharing, multiple bands, and multiple mode in all one for the low cost and sharing mode. It's really good and fast for the ROI for our operators or the toll customers. And also, this system of the active DAS is a three-level architecture. It's including the MU, EU, and the RU. The MU is the master access unit, which receives the multiple operator signal by the radio frequency band cable and transform into the digital signal into the EU by the fiber cable. And the EU is the extension unit, which realizes the signal distribution and the power supply to the RU by the hybrid cable. The RU is the remote unit, which includes the internal antenna to realize the indoor signal coverage by the remote unit. So for the whole system, we had the highlights, including the high performance, ultra wideband, and can realize the end-to-end remote monitoring and debugging by our own MS system. And also it has a flexible networking, which can realize the hybrid starting and also the cascading link for the whole system. And each MU can support 128 RU maximum. Okay, so as we all know, there are so many indoor DAS systems to realize indoor coverage. So which one is a better choice for our operators or our customers? So as we all know, when comparing these different indoor DAS coverage solution, we see that the traditional passive DAS or the digital DAS or active DAS, each solution has their own strengths. So as our comprehensive calculation shows that the active DAS solution has will be more cost-effective option for the 5G indoor deployment compared to the passive DAS and digital DAS, especially in the large and medium-sized building for the multiple operator sharing. Okay, so second part is about the repeater. The repeater is just like the microphone and speaker law we use, which can only amplify the singular coverage of our base station, but cannot produce the signal or produce the capacity of the signal. So firstly, let's see the application scenario of our optic fiber repeater. So for the optic fiber repeater, it's mainly used in the office building and the suburbs. So for this, first scenarios, the main challenge is the lack of the singular source and the high cost of the traditional indoor DAS solution. So by this, the new optical fiber repeater solution can not only extend the coverage of the single source, but also can enhance the network stability in wild coupling mode, and can also lower the cost of our operators. For the high-rise building, like the residential area, the main pains is how to achieve the residential coverage without building IBS quickly. So we can use our optic fiber repeater plus the spotlight antenna to realize the quickly indoor singular coverage. So by using the spotlight antenna, we can realize the singular penetrate into the indoor buildings. So it's a really good way for the residential coverage without building an IBS system. So the third application scenario is about the road and the tunnel. As we all know, for the road and the tunnel, distance is so long. So how to resolve this solution, these issues? So We also can use our optic fiber repeater and to resolve these problems. So we can use our MU and plus RU, and by using the RU cascading to realize the long distance single coverage. They are low loss due to the wiring coupling method suitable for long distance, and also they can help base station extend the coverage of the distance and improve the resource utilization and can lower cost of the operator construction. And the maximum of our MU to the RU distance is about 10 kilometers. So the optical path also can support 1+1 backup. So it's really a good reliability for this solution. And they support customized reference band with a high-level output power reaching 100 watts for each port. And also the bandwidth can reach the 100 for each carrier as well to meet the 5G requirements. So additionally, this is the wireless repeater introduction. For the wireless repeater, the main application scenario including the indoor and the outdoor. The main value lies in the wireless repeater is low need of the transmission facilities because it transmits the signal by the wireless coupling. So, and also this solution will have the less investment and the quick results, and can expand the base station coverage in low traffic areas such as the underground and the small office or the rural area. So we can also offer both the high power repeater and the low power wireless repeater depending on our different customers' requirements. So for all this solution don't require the fiber optical resources and can support the remote debugging and alarming by the NMS system. It also can receive the base station signal by the donor antenna and then to amplify the signal and to realize the signal coverage by the service antenna. And all this solution can support the ICS. The ICS, which means the interference cancellation system. So due to this system, in the multiple mode, we can support everything in one pole when we do the installation of the outdoor or the indoor coverage. So this solution can really decrease the total cost for our operators. In the contrast, for the low power solution, the low power repeater only have low power output power, and other things is the same similar as the high power repeater. So this solution is mainly used in the small VIP scenarios, which mainly to solve the customer compliance and to realize the continuous coverage, enhance our user experience. So this is the different kind of solution for our micro power repeater. For the different scenarios, we will use the different micro power repeater solution, such as the elevator type is, as you can know, is mainly used for the elevator scenarios. So in this solution, we have the MCU, the main control unit, and also the car unit. The main control unit will receive the signal from the outside and then transmit the signal into the car unit. The car unit will realize the signal coverage in our elevator car for the indoor. And for the common time, it's mainly used for the small and the medium size Mars. It's only have one host repeater to realize the small area single coverage. And the last one is the distribution type. So this solution is a three-level architecture as well, which include the AU, EU, and the RU. For the whole system, we can cover the parking lot, which can reach the 10,000 and even 20,000 square meters parking lot. It's really a low cost and easy construction and a short period solution. So the last one is the future development of the repeater. So there are two main things I want to mention. The first one is for the spectrum utilization. As we all know, the spectrum is divided into the FR1 and the FR2. For the FR1 is the low frequency band for the wide coverage. So as we all know, the competition among the various operators about the spectrum utilization is fails. And the second one is for the FR2. So FR2 is the higher frequency band and is it has the large bandwidth and the clean spectrum and the low interference. And it is used as the subsequent extended frequency of the 5G. So second one is satellite communication application. So for the repeater, satellite are an effective supplement to ground communication system or the low altitude network application. Moreover, the concept of the satellite communication relay raises an interesting question. So can a repeater breathe a new life in the future? So by integrating the repeaters with the satellite communication, can we further enhance the reliability and reach the 5G network? So it's really worth to explore in the future together. So also, this is all I want to share with you. Thank you.